This is Precalculus Chapter 8, Lesson 1 on page 524. Graphical solutions to trig equations. There are two methods for solving trig equations graphically with your calculator. The first one is the intersection method. An intersection means where the graphs intersect. So you're going to have a y sub 1 and a y sub 2 in your calculator, and you're going to graph them, and you're going to find where those two graphs intersect using second trace intersect. We're going to work some in just a minute. So that's the first method. The second method is the x-intercept method. In this case, you're going to just have a y sub 1. Your equation is going to be set to 0. So all your terms will be on one side, 0 on the other side. You'll put that one equation in y sub 1, and with your calculator, you'll do second trace 0. So the two different methods. We use this with functions. Now we're using this with our trig equations. All right? Now, what's important with trig is you have to take note of the period of the function. All right? So let's talk about that before we get to the actual problems. Remembering from chapter 7 that the standard period for the sine and the cosine is 2 pi. All right, what's the period? That's the period it takes to complete one cycle of the curve. All right, so remembering the sine starts at 0, goes up, down, like that. So from 0 to 2 pi, it completes one cycle. So its period, unless it's been transformed, is 2 pi. Cosine is also 2 pi. Remember, it starts at 1, goes down, and comes back to 1. But on the x-axis, it's 0 to 2 pi on the horizontal axis. All right? Unless it's been transformed, it's 2 pi. For the tangent, the period is pi. Remember, it goes from negative pi over 2 to positive pi over 2. And it has asymptotes at every odd half pi because that's where it is undefined. You have a 0 in the denominator. It's where the, remember, the tangent equals the sine over the cosine. That's where the cosine is equal to 0. All right, so you have to take note of the period and if that has been transformed. And from lesson 7.3, we learned that your function looks like this. I'll just use the sine function, and that the b value dictates what the period is. So the period is equal to 2 pi, your standard period, over the value of b, such that if I had, and this A, that's your amplitude. That's how high the curve goes up above your imaginary x-axis and how low it goes below your imaginary x-axis. So if I had f of t is the sine of 2t, my b value, of course my amplitude is 1. If there's nothing there, it's 1. That means it's going to go up to 1, down to negative 1. This 2 dictates the period. You do the 2 pi over 2, so pi is the period. That means between 0 and pi, it's going to complete one cycle. All right? So we have to keep the period in mind when we are graphing these, because then that will dictate what window we want to see in our calculator. All right, I'm going to help you walk through these in your calculators. All right, first thing, Get your calculators out, check your mode. Make sure your mode is in radians. So tab down to radians and hit enter and keep it in radians until our last example. All right, so looking at example 1 on page 524, we're going to use the intersection method. That means we're going to have what's on the left-hand side of the equal sign will be in y sub 1. What's on the right-hand side of the equal sign will be in y sub 2. So you go to y equals. I know it's been a while since we've done this. I'm going to clear out what's there. Also, make sure none of these plots are highlighted. So if a plot is highlighted and you just go up, you hit enter and go down and it changes it. See, mine wasn't highlighted. Now it is. The plot's on. I'm going to go take the plot off. I tab up. I hit enter. I go back down and the plot is off. All right, so radian mode, no plots on. Y sub 1, in example 1, is tan x. You just do tan. Here's your x. And close your parentheses. And hit enter. And then, making sure I did that right, y sub 2 is going to be 2. All right, so let's think about what this is going to look like. The first curve is going to graph the tangent. The period hasn't changed. There's no b value. So what I should be looking at is from negative pi over 2 to pi over 2. That's going to show me one complete cycle of the tangent curve. This 2, that's going to be a straight line at y equals 2. So for y, I want to see 2. All right, so if I go into my window, I always look at my window first. I want to set my window to negative pi over 2. So I'm just going to do it. Here's your negative, right? I might just go from negative pi, actually. So negative pi, that might be easier. And it's just second and the caret for pi. And then I'm going to go to pi for my x max. Then for my y min, I want to see the 2. But I'm going to go ahead and leave it negative 5 to 5. And then graph it. See, right here. Here's that one cycle. And then here is y equals 2. Here's that one point that I want to find. This one is going to be pi away from this point of intersection. So you do second, trace, which is right here, trace, and we're going to do the intersect, which is 5, and hit enter. And see my markers here. Remember, we're going only left and right, not up and down. So I want to go back close to that point of intersection, and I hit enter. That's on the first curve. It typically stays right there. It's still close to the point of intersection. I hit enter. My guess, I hit enter. And see, that's my x value, 1.1071. So that's the answer. X equals 1.1071. Now, I have to note my period because that solution is going to repeat every pi distance. So it's plus and minus k pi. And it's just pi. Because it's every pi, okay? All right, that's the intersection method. The x-intercept method is when we're setting it equal to 0. All right, so looking at example 2, we have the sine of x equals negative 0.75. I want everything, all of my terms on one side of the equal sign set equal to 0. So I'll add 0.75, set it equal to 0. This is what goes in y sub 1. All right, and then I take note of my period. My period is 2 pi because this is 1. So my period is 2 pi. So on my window, I absolutely want to see 0 to 2 pi. That's going to be one cycle. All right? So I go back into y equals. I'm going to clear out what's there. Clear, clear. And I'll go back to y sub 1. I'm going to put the sine of x, close that parentheses, plus 0.75. All right, now I'm going to go look at my window because in my window I want to see 0. I might go from negative pi to 3 pi. So I see 0 to 2 pi, all right? So that's what I'm going to do. It's already negative pi. Then I'm going to go to 3 pi. So you just hit 3 second upward caret. All right, now my amplitude is 1. I can leave it at negative 5, but it will only go up to 1 and down. Okay, there we go. All right, so look, here is you could really go from here back to that same place here. So I want those 2 zeros. So you're going to do second, trace. Now we're going to do 0. And remember, it goes from left to right. All right, so here's my marker. I want to go right above because we're going left to right. So left is above on this side and right is below. I'm watching my y value. My y value is positive. Oh, now it's negative. Okay, so left is when y is positive. I hit enter. Right bound is when y is negative. I hit enter. And then my guess. So that's one of the solutions. X is 3.9897. 3.9897 plus and minus 2 pi. Because that's our period, 2 pi. Or 2k pi. Because why do I write the k? Because it's plus 2 pi plus 2 times 1 pi plus 2 times 2 pi. K is any value. All right, so it's not just 2 pi, it's 4 pi, it's 6 pi, it's 8 pi. And it's negative 2 pi, it's negative 4 pi, it's negative 6 pi. Because of that cyclical nature of it. All right, so now we've got one answer. Now we want the other one. So now left to right, from left to right on the second one, my left bound is going to be negative. So second, that was wrong, Paula. Clear, clear. I just cleared it. Let me put it back in. Sine x plus 0.75. All right. Second, trace 0. Okay, let's see where I had to regraph it, where my marker is. Okay, my marker's still up there. We already did that one. Now I'm watching. See, the y is negative. I'm looking for it to change to be positive. Okay, left bound is negative because remember we go left to right. All right, so then enter, and that's the answer. So this 0 is x equals 5.4351 plus or minus 2k pi. K being any number. 1, 2, 3, 4, 5, 6, 7, all numbers actually. All integers, okay? All right, so that is the 2 methods. Now, and those are your basic equations. When we have the sine, we've not adjusted the period. We just have the sine or the cosine set equal to a value. Now, example 3 is more complicated. You have more terms and you have the sign squared. So looking at example 3, this is how you should put it in your calculator. So you're going to square it outside. That is how I'm going to put this in my calculator. I look at the period. Has the period been changed? There's a 1 before the x in the b position. There's a 1 before the cosine. So the period to complete it is still going to be 2 pi. My amplitude at some point, it's going to go to 3. All right. So I will put this, go back to y equals. I'm going to clear what's there. And I'll put this in. All right, see? That's just how I put that first term in. Minus cosine x minus 2. All right? And then we're going to look at our window. I probably want to see, I've got it at negative pi and positive 3 pi. I think that's all I want to see because I'm expecting one cycle then. Actually, I'm going to change this to 4 pi so that we can see that that cycle finishes. So at 4 pi, then 5 should give us enough to be able to see that whole graph. So let's graph it. Okay, this looks like one cycle. See, there's one cycle, there's the second cycle. So I'm only going to look at one cycle because I'm going to say plus and minus 2k pi. So I'm going to find this solution, this solution, this solution, this solution. We'll just find the first 2. But there are 4 solutions for this one graph. And they're all plus 2k pi. All right, so we'll just find the first 2. We do second trace 0. And remember, it's left to right. So I'm over here. I want to go back to the right. So the left bound is negative because we go left to right. So I'll hit enter. It's negative there. Then I'll move up. So that's the solution. 1.15, 1.1216 plus 2k pi. Then the next solution, second trace, 0. Now, my y value is positive because we're going left to right. So when I go negative, I go back to the left. That's positive. That's negative. And it would be that plus and minus 2k pi. Then you would find this solution plus minus 2k pi, this solution plus minus 2k pi. And then you've got it, because this solution from here, let me use my pencil. From here to here, the distance is 2 pi. All right, so it just repeats itself over and over again. Okay, example 4 is another more complex problem. So my preference is the x-intercept. So for example 4, I'm going to set it equal to 0. All right, so we have the tan of x equals 3 times the sine of 2x. We'll subtract this whole term and set it equal to 0. The tan of x minus 3 times the sine of 2x equals 0. All right, what's the period here? It's pi, because your b value is 1. Now this one's been transformed. So it's 2 pi over the b value which is pi. So because we have the tan, I'm expecting to see from negative pi over 2 to pi over 2 a complete cycle. I probably will still go maybe negative pi to 2 pi to see what I see. Probably negative pi. I can leave it at 3 pi. That's where I'm set. But here's where I'm looking between those two values. All right, so I'll go in and I'll just do the tan of x, close, minus 3 sine of 2x, close. All right, making sure I put that in right. And my window looks like that. I'm going to change, because the tan goes way up, I'm going to change that to maybe negative 20, my y, to positive 20, just so I can see the whole curve. Because remember, the tan, unlike the sine and cosine, goes y to positive infinity and negative infinity. All right, so we'll graph it to see. All right, so I'm thinking this is one cycle, and it repeats, repeats, repeats. All right, so this is one cycle. So that's from negative pi over 2 to positive pi over 2. I just need these solutions, 1, 2, 3. So left to right, we'll do second trace, 0. Where is my marker? Okay, it's way over there. So I'm going to go way back. It's going to go down. It's going to jump. So left to right, that's going to be negative. My y is going to be negative. So I hit enter. Then I go positive, enter, and guess is just entered. That's my first one. And it will be plus k pi. It will be this number plus minus k pi, because the period is pi. We'll do that next one. Second trace, 0. Now my y value from the left side is going to be positive. And the right will be negative. All right, so that's 0, 0. And then you can find this third one, and it's plus k pi. All right. Now the last example is in degree mode. So I still want to see a complete cycle, and when trig is in degree mode, and just think about it on the unit circle, it's from 0 to 360 degrees. So I'm going to go back and set my mode now. Since this last problem is in degree mode, I'm going to set it in degrees. And when I think about my window, I'm not thinking 0 to 2 pi is a complete cycle. I'm thinking 0 to 360 degrees is a complete cycle. All right, so this is how I will enter this equation into my calculator. It's 2 times the sine of x squared minus 3 times the sine of x. Remember, parentheses are important. Minus 3. This is how I'm going to put it into y sub 1. I've changed my mode to degrees. I'm going to y sub 1. I've got to go make sure. Yeah, it's in degree. All right, so it's 2, open parentheses, sine x, close, close, squared. And so I put that first term in. Minus 3, open parentheses, sine x, close, close, minus 3. Now, for my window, let's look. So the period is still 2 pi because there's no b value, or b is 1, all right? So when I look at my window, I'm going to go a little bit negative so I can see it. So maybe we'll go negative 90 degrees. That's one quadrant. Negative 90. And instead of just stopping at 360, I'm probably going to go to 400. And the amplitude is at most 3. So maybe I'll go -4 to +4 so that I can hone in on where it's going to cross the x-axis. And then I'll hit enter. Okay, now here's what I expect to see. And then it repeats. Look, I'm going to lower this and make this a little wider so we can see. Maybe I'll go to 720 so you can see that. I'll go -10. I'm going to reset my window so you can see the different cycles. All right, so it goes down, sort of flattens out, curves, down, flattens out, comes up, and curves. All right, so the zeros that I need are in this first. Actually, I could do here. If I start here, I want to end here. So if I start here, I'm going to go up, up, and then back to here. If I just start on the positive x-axis. So I'm going to do second trace 0, find that one, left to right. Second trace 0. Let me find my cursor. Oh, there it is. I'm going to find these two. Left to right, that y value is going to be negative. All right, that's the left bound. Right bound's going to be positive. So it's going to be that plus and minus 2k pi. And the next one, second trace 0. Left to right, above it is going to be the left bound. Because remember, that's how our x value here is going to be smaller. And that's what it's looking at, your x value. But I look at my y value to tell me if it's positive or negative. And that's the other one, plus minus 2k pi.